Hello, we're going to begin chapter 4 in our study of triangle. Now, where we begin is really looking at what type of triangle we have. So we want to classify it and kind of review types of triangles that we should already know and really look at solving for angle measures in triangles. Now, hopefully you had the chance in class to look at a construction of a triangle and analyze its angles and see that the angles of a triangle equal 180 degrees. That's kind of going to be some base knowledge that we're going to use as we work through these two lessons. This video is going to cover lessons 4.1 and 4.7 in your text. So don't be afraid to go back there and kind of reference that and look at some concepts. But really take the time to make sure you're filling in good notes so you have those detailed examples to be able to use when answering your questions. Let's go ahead and take a look at the notes themselves. A little bit bigger so that we can work with this. All right, so we're going to kind of start with some prerequisite knowledge, some things that we should know already. If we're going to look at classifying a type of triangle, the first thing we're going to do is look at it by its angle. Okay, we've done this probably for several years now. One of the first things we're kind of trained to look at is, does it have a right angle? If it does, we call that a right triangle. So we could classify our triangle as a right triangle if it includes a right angle. So that would be classifying it by angle. Okay, if it contains an obtuse angle, then we're going to call that an obtuse triangle. Okay, so we could say that that triangle is obtuse if it contains an obtuse triangle. Now, if it does not contain a right angle or an obtuse angle, it has to have 3 acute angles, and then that would make an acute triangle. Okay, so keep in mind, if it's a right triangle, it has 1 right angle. If it is obtuse, it has 1 obtuse angle. But if you say it's acute, it has to have 3 acute angles, okay, to create the triangle itself. Now we have one more blank here because we have a special type of acute triangle, and that's when it is equiangular. If your triangle happens to be equiangular, that means that all angles in that triangle are equal. Okay, well, if we know that all the angles of our triangle are 180 and we have to have 3 equal ones, we can divide by 3, and that would mean we have 3 60-degree angles. Okay, that's the only case which it can be equiangular. If we decide to analyze our triangle by its side length, okay, we could say that it is scalene, okay, meaning no equal sides. We could say that it is isosceles, okay, meaning it has 2 equal sides. And we could say that it is equilateral. An equilateral triangle, okay, has 3 equal sides. All right, so now we just want to kind of look at a statement or a conclusion that we can make. Okay, if a triangle is equilateral, it must then also be equiangular. So as a logic statement, we say a triangle is equilateral if and only if it is equiangular. If and only if is often used when writing logic statements, and sometimes they even abbreviate that as IFF. That does stand for if and only if. So if you see that, that's the case. So anytime you see an equiangular triangle, it has to be equilateral. Or anytime you see an equilateral triangle, that means it will have to be equiangular. Okay, those must occur with each other. And another conclusion that I want you to kind of draw, okay, about your triangles is that there can only be one right angle, okay, or one obtuse angle in a triangle. Now I want you to think about that because a right angle is 90 degrees. Well, if you had two 90-degree angles, you already have 180 degrees and you don't have anything left for your third angle, so you can't make a triangle. Okay, now obtuse angles are even bigger than 90, so then those two together would already be over 180 and couldn't create a triangle. So if you're going to have a right angle or an obtuse angle, you can only have one, okay, in the triangle itself. Okay, so let's look at a couple of pictures here and try to classify our figures. And what I will even do, if need be, okay, is kind of show some measurements in this case. Okay, so here I do have a 110-degree angle. So that angle right away is obtuse. So as soon as I know I have one obtuse angle, I know I have an obtuse triangle. So we're going to say this one is obtuse. And if we look at our side lengths here, these side lengths we might want to kind of look at the measurement of. So in this case, I've got 2.4 centimeters as my side length. Okay, over here, it's only 1.8. So definitely different side lengths, okay, between those two. And then my obtuse angle clearly created, okay, a much larger side. So 3 different side lengths in this case. So then this would be scalene. So I would consider this triangle to be obtuse scalene. So there's the key idea when you're classifying. You always have to classify it by its angles and its sides. Okay, so kind of careful there. Okay, here I can see I have 3 equal sides. Well, 3 equal sides will make that equilateral. And then I should note, if it's equilateral, it must also be equiangular. So when I describe this, I want to describe it as equiangular, equilateral. Okay, you might notice that these are all acute angles. Okay, so it could be acute equilateral, but the most specific or the best way to describe that is equiangular, because then I know I have 3 60-degree angles within that diagram. All right, in number 3, it says, find the value of x, then classify a triangle M and P by its angles and sides. Okay, so if I take a look at this, I should recognize in this case that I have, okay, 2 equal sides marked on here already. Okay, but I also have 3 angles here, so I can just make those equal to 180. So x plus 65 plus x plus 15 has to equal 180 degrees. The triangle equals 180. And I get 2x then. 65 and 15 will give us 80. If I subtract 80, we've got 100. So then x is going to be 50. So that's going to make this angle, okay, at the top, 50 degrees. Okay, and then 50 plus 15 equals 65 degrees. Okay, so you can see this is not quite drawn to scale. That's one thing I want you to kind of keep in mind with your figures. They're not necessarily drawn to scale, or those measurements aren't going to match up with exactly what that should be. But we can see then that those angles will add up to 180 and make a triangle. Okay, so that is true. Okay, it has all acute angles, so this one would be acute. And it has 2 equal sides, so then this would be isosceles. So acute isosceles. Now, one thing I want you to kind of just recognize, because this comes up a little bit later in our lesson, okay, but 2 equal angles, 2 equal sides. Okay, just like your equal angular and equilateral, right? 3 equal sides meant 3 equal angles. Okay, so then another conclusion you should be thinking in your mind is if there are no equal sides, there should be no equal angles. Okay, just kind of think through those, okay, as we begin to set some problems up to solve later on. Okay, and then at the bottom here, we just want to review, okay, naming a triangle itself. Okay, if we are going to name the triangle, we want to be able to move around the triangle in that order with your vertices. So for instance, I could say that this is triangle ATC. So I could go from A to T to C to draw that triangle out, okay, or move around that triangle. Okay, it then has the vertices AT and C. It has the angles AT and C. We usually only use a single letter now to describe, okay, the angle at that vertex. And its side lengths are going to be segments, so segment notation there. It has sides CA, AT, and TC. Now when we name the triangle A to T to C, okay, that's how I went around. But there would be other ways that I could state that. Instead of triangle ATC, I could say that this is triangle TCA. So I could start at T, go to C to A, okay, to make that triangle. Okay, and so on. There would be different ways that you can write that, but make sure that's the way you move around the triangle itself. We always use a little equilateral triangle as our symbol for triangle, just universally. So that goes in front as its notation. All right, so a couple reminders about the angles themselves again before we really start solving is we have what's called the triangle sum theorem. So all the measures of the angles of a triangle have to equal exactly 180 degrees. Now a corollary, or what we can determine from that, okay, is that if we have a right triangle, the acute angles of a right triangle have to have a sum of 90 degrees. Now that's because the right angle has to be 90. So if all 3 angles have to equal 180 and the right angle is 90, that leaves 90 degrees left for the 2 acute angles. So you have to have 2 acute angles in a right triangle that add up to 90 degrees. Okay, these are the ideas that we want to kind of use as we continue to solve for different values in the triangle themselves. So when we see this first one, I see that I have a right triangle. So in a right triangle, I know my 2 acute angles have to add up to 90 degrees. So if this one's 70, that means x immediately would have to be 20 degrees. And I can see that 20 plus 70 equals 90. Okay, or if I were to take 20 plus 70, which is 90, plus 90, that's 180. So all 3 angles of that triangle were 180 degrees. Okay, when we go to, okay, number 2, I know if I were to put that as an equation, I could add these 3 together to equal 180, and then just start with 180 and subtract these 2 values to see what I have remaining, and that will leave 63 degrees remaining for, say, the 3rd angle of that triangle. Okay, or as we begin to add in algebraic expressions, this is where it's important that we do write the equation itself. So in this triangle, we have 3x minus 1 as one of my angles, plus 31 plus 90, okay, would equal 180. Okay, so now if I were to simplify that, I have 3x. Let's see, 30 and 90 would give me 120 if I add those values together. subtract 120, and then x would be 20 degrees. Now, that's the value for x. So if I wanted the angle measurement, I have to plug that back in, remember. So 3 times 20 minus 1. So that'd be 60 minus 1, or 59 degrees. Okay, and then you can see, we can check that, right? 59, 31, okay, is 90, plus 90 would be 180. Now, if you recognize this from the beginning as a right triangle, you knew that these two would have to equal 90. So you could have also said 3x minus 1 plus 31 is equal to 90, and just simplified that equation a little bit quicker. So it would be 3x plus 30 equal to 90, 3x equals 60, and x equals 20. Okay, so then still the same values. But again, once you find your value for x, make sure you're taking that angle measure, plugging that back in, to make sure you can calculate what that angle measurement should be. All right. Now, what I want you to have an idea of, okay, is the difference between an interior angle and an exterior angle. Interior is what we have been solving for so far because it's in a triangle, or on the inside, it's interior. An exterior angle, okay, by contrast, then has to be on the outside. So if we want to create an exterior angle on a polygon, okay, and here we're only using triangles, we're just going to take a side length and extend it. If we take one side of our figure and extend that, you can see that at vertex C right here, okay, I have angle C, which lies on the interior of that triangle, and then angle 1, which will be the exterior angle in that triangle. Now we have a theorem given to us about exterior angles. It tells us that the measure of an exterior angle in a triangle is equal to the sum of the measures of the two remote interior angles. Now when we say remote interior angles, we're talking about the interior angles that it's not connected to. Okay? The vertex here is at C. So that's connected to the interior angle at C. So don't use that one, you're using the other two. Okay, now hopefully this makes sense to you if I give you some measurements, okay, to kind of begin with. Let's say that angle A, I don't know, was 40 degrees, and angle B was 90 degrees. Okay, if I use my exterior angle theorem, the exterior angle right here, angle 1, should be 40 plus 90, or 130 degrees. Okay, what we also know in a triangle is that the three interior angles of my triangle have to equal 180. So if this is 130, okay, that would leave 50 degrees, okay, for my angle on the inside of my triangle. Then I should recognize that an interior angle and an exterior angle make a linear pair because it makes a straight line right there. So a straight line must also equal 180. And you can see 50 and 30 add up to 180 degrees. So it always works itself out because a line is 180 and the angles of a triangle are 180. Okay, as we saw at the beginning of this chapter with our construction. Okay, let's go ahead and kind of look at that and see how it would look in a diagram. So in here, in number 7, we don't have exact angle measurements as I just put in that example. So we have to write an equation. So the exterior angle here, 2x minus 5, has to equal the sum of the interior angles it's not connected to. So that would be x and 70 in this case. And then I'd work my way to solve that. So subtract x, add 5, and we get x equals 75. again, it wants us to find the measure of the exterior angle. So now I'm going to take the 75 and plug that in. So 2 times 75 is 150. Minus 5 would be 145 degrees for the measure of that exterior angle. Okay, so again, anytime you solve for a variable in geometry, look to see if you need to plug that in, okay, depending on the question in your problem. All right, same thing with number 8. My equation should then be exterior angle of 3x plus 6 equals the sum of the other two interior angles. Okay, subtract 2x, we'd have 1x. Let's see, I want to put 24 and 18 together because those are like terms. That would give me 42. Okay, subtract 6 from each side then, and I have x equal to 36. Again, then if I wanted the exterior angle, I've got to plug that in. 3 times 36 plus 6. So I get a measurement of 114 degrees if I were to plug that in. Now, just as a little extension here, now what we should be able to do is take a diagram and truly solve, okay, for different angle measurements. And here I'm looking for this angle x between, okay, those two side lengths in that triangle, okay, with my vertex right here. So we're going to put a lot of concepts together from chapter 1 all the way through chapter 4 here. What I should notice is I have a right triangle and I have one acute angle of 34 degrees. So if I were to take 90 and subtract 34, I would get an angle measurement of 56 degrees, okay, which would go right here in this triangle. Pretty small, I gotta kind of write that in. That one would be 56 because here's my right triangle. Now if I look at this triangle, I also know that I've got 40 plus 80 plus x over here, which would have to equal 180. Okay, so 40 and 80 is 120. Minus 180 would give us 60. So then this angle over here has to be 60 degrees, okay, in our little triangle. And then we'd have an angle right at the top because this is a little triangle, which also has to be 180 degrees. So then I would take 180, subtract 60, and subtract 56 to see what that angle at the top would have to be. 180 minus 60 is 120. Minus 56 would leave us with 64 degrees, okay, up at the top. Okay, so that would leave this angle here at 64 degrees, meaning its vertical angle directly across from it must also be a 64 degrees. Okay, so in this case, we've got to kind of solve for lots of different values around that before we can get to that value. All right, now we're going to take our solving process just a step further and specifically focus on equilateral and isosceles triangles. So we have a couple of theorems that go with this in here, but there's a couple of things that we should recognize. Again, if a triangle is equilateral, it has 3 equal sides. But if it has 3 equal sides, it must also then have 3 equal angles. Well, if it has to have 3 equal angles, again, all angles have to add up to 180. If we divide that into 3 equal parts, each one is going to be 60 degrees. Okay, isosceles triangle works a little bit different. Okay, your isosceles triangle theorem, okay, tells you that the base angles of an isosceles triangle are going to be congruent. And what I want you to recognize is where we have to place those base angles. So we know that in this isosceles triangle, these are the two equal sides. Okay, well, this side length right here was created by its measurement directly across from it. Okay, the number of degrees that I open this angle creates this side length at the end of that triangle. If I were to make that triangle bigger, it would make that side length bigger. Or if I were to make this angle smaller, it would shrink that side length. Okay, the angle measurement always creates the length of the side directly across from it. So if this side length here is equal to this one, that means that this angle here has to be congruent with this angle here, because this angle is what created that side length. So we always look, if two angles in a triangle are congruent, the sides opposite the angles are congruent. Okay, so two angles are congruent, the sides opposite them are congruent. Okay, and the same way, but you always want to kind of look at what those measurements are. Okay, so if we look at a couple examples here at the bottom, we have two equal angles marked, okay, which were two base angles in this picture. Then the sides that those angles create must also be equal. So I go directly across the triangle from this angle, and we have the side length of 40. And I go directly across the triangle from this angle, and we get the side length of 5x minus 5. So if I wanted to find the value of x, I would have to say that 5x plus 5 has to be equal to 40, because this side length has to be the same as this one. Subtract 5 from both sides, we'd get 5x equals 35. Divide by 5, and x would be equal to 7. Okay, same thing in here. We've got three equal sides, or equilateral triangle. So then that would have to create three equal angles. We know that if we have three equal angles, each one has to be 60 degrees. So 4x would equal 60. If we take 60 and divide that by 4, we get our value of 15 for x. Okay, and then just working through that here one more time. Okay, in this diagram, that's a little small in this picture, so let me make this a little bigger so we can see, okay, what's happening in this picture. Okay, first of all, here's the two equal sides. So again, the angles opposite them are the ones that have to be congruent. So that tells me that 5y, and I think this means minus 3, okay, then has to equal our measurement of 72 degrees. We'd add 3 and we get 75. 75 divided by 5 would give me a y value equal to 15. Okay, but if we wanted to find x, we know that if this angle is 72, this angle has to be 72, and then we can add in x, and the three angles of the triangle have to equal 180. So 72 plus 72 would give us 144. And then 180 minus 144 would give us a value for x at 36. All right, so just a couple key reminders. The three angles of a triangle always have to give us a sum of 180 degrees. Okay, immediately look at your diagram before you start solving and think about what type of triangle you have and how many acute angles you have, okay, or, okay, do you have a right or an obtuse angle in your diagram? All those ideas, the type of triangle you have, helps you solve it. And again, 2 equal sides means 2 equal angles. 3 equal sides means 3 equal angles. Or 3 different angles means 3 different side lengths. And think about how the type of triangle creates specific values that have to occur in the diagram itself when you're solving. And then just check your work to make sure everything is correct, okay, before submitting an answer. All right, good luck with your work in these lessons.